Our next task is to perform feature extraction. This is very useful to understand the combination of attributes that can create features that are the most important ones for our analysis, for our machine learning model. So we would like to identify the most important features, and then you will get from those features into the attributes which are the most important attributes of the customer that will predict certain values. This is the idea. The same as in the previous labs, in the previous exercises, I'm going to refresh my data frame. In this case, it's an OML data frame I'm creating for the same table in the database with all the insurance customer information. And then I'm going to drop the LTV column, numerical column, with the actual values of the lifetime values of the customers. So this information is not required because we are trying to make the feature extraction based on the classification labels we have for the customers, and we want to understand how this classification can be improved and what features are the most important ones. Again, I'm going to split the data into training and testing. I'm going to use the default ratio 70-30, and then I'm going to specify some parameters, some settings for my singular value decomposition I'm using for this for the feature extraction in this case. So actually, I'm using the principal component analysis for the scoring in this case, and I'm going to enable also the details on my model. So these are the only two settings I'm specifying in my settings list. Here, this is a list. And if you want to find all the settings, you can click on the link here and you can read the documentation about all the available settings for the singular value decomposition model. And now I can create my SVD model, my actual model using the settings I specified in the previous block. And if you want to learn more about how to create customized models, and if you want to understand completely the SVD singular value decomposition model, again, I advise you to click on the link and you'll get the documentation. And then I'm going to fit the model with the training data. In this case, all the data is in one single matrix with both attributes and labels. And I'm using the cust ID column to identify individual records in my data set. And then when the model is created, I'm going to print the details of the model. So you can see here, the mining function is feature extraction. It's a singular value decomposition model. I have specified the scoring and the details, the OM, the details enable. And then I have the computed settings, number of features, and the number of components. And then I have all the attributes in my data set for my customers, the attributes I have in my table, all the columns I have in my table. Partitioning, and then I have the features, and here are the features with their value, and we have features comprised of single attributes, but also we have features comprised of multiple attributes. We have here all the features, and then the values and the combinations of attributes creating features. So here we have the 50 columns, the 50 dimensions we have specified, and we have given the number of features to generate to identify from all the attributes we have for these customers with their values. And now I can use the model to make some predictions on my test data just to test it, the singular value decomposition. And this is the feature which is the most important for this customer to have this actual actual label here. So now I can start identifying or analyzing what are the features, individual features in my model, which are the most important ones for a certain for the customers to have a certain label. In this case, I'm looking at the label very high. This is the label I'm trying to isolate, and here I'm creating a summary of the features which are influencing the customers to have this particular label for the column LTV bin, for the classification column we are using. We have used in the previous models for classification, and then I'm going to order them by their number in descending order. So let me show you how this works. So we have identified the features and the importance, and in how many cases these features are basically definitive or important to define those customers as very high. So we can see here are the features IDs, and this is the number of customers from my testing data in which these features are the important ones. How about the features that are important to classify a customer as a high customer? And this is the output here with the features, the ID of the feature and the number of customers which are in my data set and that are basically classified as high customers, high value customers, using this, having these features in particular. And again, I can do the same with medium and low. I'm going to run them just to show you the output for each one of the labels. But then I'm going to do a reduction. So this, in this case, the algorithm doesn't perform attribute reduction or a feature reduction. It's going just to identify them and list those features. But the operator is in charge of using those features in the new model and having those features as the primary ones in the machine learning models they create. So the algorithm doesn't make it just ranking the importance, but it doesn't actually select the features. No, this is an attribute feature selection again. Anyways, it's the same. So it doesn't make a reduction of on those features. It's exactly the same way and in attributes importance. So anyways, going back, I'm going to perform now the reduction, as I was saying, and return the features, the two features that are the highest top values. So I'm going to return top one and top one value. Let me see. And here I have the highest feature for each customer to be classified with the value and the classification value it has. And then I have the top one and top two. These are the top two features for each, for this customer in particular, to identify this customer as a high value customer. And then I have the second customer in this case. This is the customer ID. I can add more columns if I want, but the table will be bigger and it will be more difficult to read. And then I have the classification value. I'm trying to predict the features important for this value. And then the top one feature is feature number 1, and the second one is feature number 3 for this customer to be identified as a very high customer value in this classification. And then now I can list the attributes of the customer which are important for a feature in particular. So I'm going to list the most important customer attributes for the most important feature. So I'm going to take only this column, the top one, for each one of the customers, and I'm going to show the exact attributes. Let's say that the most important attribute for this customer, for this attributes. So for feature ID 1, the most important attributes, I don't know if I explained it properly, but anyways, for the most important feature, which is feature number 1 in this case, for the feature ID 1, I'm actually doing a filtering here on feature number 1. So it's not the most important feature, it's the feature number 1 with the ID 1, feature ID 1. So here I'm basically doing a filtering. Then I'm taking the most important attributes in the customers table for this feature. And then I also show you the importance in a subunitary format. Like the biggest value can be 1 here if the feature is the only feature it has and it's the most important one. But as I have multiple features, I have different values, and the importance is specified in a value between 0 and 1. So for the feature ID 1, which is the one I'm filtering here, I'm showing you the most important attributes, ordering those attributes by the importance value, and then I'm also reducing the output to only first 5 attributes, the first 5 rows in my output, because if not, I could have a table with all 30 attributes I have for one single customer. I think 29 attributes. So this is the idea, and this way I can understand for each one of the features. For example, I can take feature number 3, which is the most important one for customer 100, to define this customer as a high value customer, and I can list the most important attributes for customers for the feature number 3. So I can, for example, I can specify here number 3 as the condition for my filtering from all the features. I'm going to select only feature number 3, and then I can run again the block. And here are the most important attributes in the order of importance. You can see here for this customer to be in high, which is the case of this particular customer to be in the high class. The most important attribute is the salary, and this salary is 98%, has a 98% importance. The rest of the attributes are basically very they have a very low importance. You can see here they are the next one is 10%, so they're very low in performance. This is the idea, and then we can do the same, and then we can concatenate this table with this table, and we can have all the customers having the most important feature, and then listing the attributes which are the most important ones to have this particular feature. This is let's say an important analysis to understand your data and then to be able to create better machine learning models. Thank you very much.